dictionary key, I've avoided the garbage allocation. Okay. So if any point of time you have questions, feel free to just raise up your hand. Okay. So let's continue. Okay, so garbage allocation, what is it? So a lot of people have been saying like, okay, avoid garbage allocation, but what exactly is garbage, right? We have two types of languages, right, in general, managed and unmanaged. So C++ is an example of an unmanaged language. C# is an example of managed language. So in language like C++, you manage your own memory allocation, deallocation, right? You assign memory, and when you don't need it, you remove it. But in C#, you request for the memory. Once you're done, you just go. Somebody else will take care of the garbage for you, the memory for you, right? And that's the garbage. That's the garbage collector. So an example that I use is, in Singapore, when we go to order food, so we get a tray with the food, right? We go to our table, we sit down, we eat. After we're done, we just leave. The table is still with the tray and the food. And then a cleaning auntie will come and collect all the trays, right? So this is like C#. You requested the memory, you used it, and when you're done, you just go. Right? Somebody else come in and clear your garbage for you, right? So this is C#. For C++, example of C++ is you go order your food, you take the tray, you sit down, you eat. When you're done, you take the tray, go back and clear your tray. So this is C++. You manage your own garbage, but in C#, somebody else manage it for you. The problem with that is you have no control over when the garbage collector comes in, right? So usually the cleaning auntie will not like wait for you to finish and immediately clear your tray. No, she'll just take her own time. She sees like a few trays on table, then she comes out and collect, right? So there's no telling when the garbage collector will come in. Why is that bad? I'll just skip this because okay, maybe I'll just go through this. So two types of data, right? Value type and reference type. Value types are simple types like integer, float, boolean. Reference types are like class, string. So value types, they exist on the stack memory. Reference type, they exist on the heap memory. Okay, two types of memory, stack and heap. So whenever a stack memory is an example of whenever your value type is out of scope, then it's cleared. So stack memory is faster and it's short-lived. But heap memory, it exists longer and it's slower, right? So allocation on the heap memory is garbage allocation. Whenever you create something that exists on the heap memory, these are garbage. And here are some keywords that will create garbage. So new, instantiate, array, string, coroutine. So avoid, why? So like I mentioned, you have no say over when the garbage collector will come in. Well, that's not exactly true, but I'll elaborate on that later. Secondly, it takes a long time for the garbage collector to scan through every piece of memory that you've used and see which one is not in use anymore and clear them. Right? So if you have a lot of memories, garbage collector will come in and look one by one which one is free, and you'll just free them. Right? So this process of scanning may take a long time. So then the result in frame rate drop, right? And also result in fragmentation. So if you look at the profiler, there's this garbage add collector tag here. If you just uncheck everything, you will see your tag here, and then you see these spikes, right? Whenever this happens, your frame rate drops. So we want to avoid these spikes as much as possible. Okay. And then just now I mentioned fragmentation. So what is memory fragmentation? So how memory allocation works is this. When you need a piece of memory on the heap memory, right? First, you will look through the heap memory to see if there's any available free memory to accommodate your request. If you cannot find any free memory, garbage collector will come in, free up any memories that is not in use, and see if we can accommodate it again. If it still cannot accommodate your request, because it doesn't fit, right? There's no space for it to fit your request. What happens is the heap memory will then grow, and then now we have more space to accommodate your request. But the bad news is this: it doesn't grow by just the amount that you want. It grows by the fixed amount. So imagine if you have limited memory, and if suddenly the heap grows like that, and you run out of memory, then your game crashes. So now you can't fit your memory. But there's a problem here, right? You can see these pockets of free memories. If you add them up, you can get a sizable chunk, right, that's usable. But then because they exist in different locations of the memory and they are too small in their own, they are wasted space. They are wasted. So unless you request for small memory, then you can fit in, but otherwise they are wasted. So you run out of heap memory faster. Okay. So I hope the artist in the room is not like, oh, this is so boring. So optimization is an art form in itself. I hope that the artist can also appreciate it. So next I want to share about displaying score. So very common. Score is usually an integer, or sometimes it's a float. For example, if it's an endless runner, you want to show how far the player has run, right? Like 120.5 meters, for example. So then you will need a float, right? But usually it's an integer or float. And usually you will display the score using UI text, right, for example. And this is what you would do, right? So the UI text equals to score.toString, right? This is usually what you do. Is this what you do? Anyone here does this? Yeah? Anyone does this? It's a very common thing. It's a very common thing. It's very easy to do. But the bad news is, toString will create a new instance of a string, and it will create garbage. So if your game needs to refresh the score very frequently, this means that like every frame you're generating garbage. And then when the garbage becomes too much, and then garbage collector comes in, collect the garbage, and then your frame rate drops, right? So for fast-paced games like this that you need to update the score very frequently, this is bad news. So how do we tackle this? How do you tackle this? Here I have a suggestion. If you're not suffering from this, if your game is not suffering from this, then it's okay, you don't need to do this. But if your game is suffering from this, the frame rate drop is because of this, then you could try this. So instead of showing it to a UI text, you can extract the digits. For example, if your score is 150, you can extract the digits 0, 5, and 1, right? Using modulus and divide. When an integer is modulus by 10, you get the last digit. When it's divided by 10, you get the remaining digits, right? So going through this loop, you can extract each of the digits. Then when you have these digits, then you can display them out as a sprite, right? So then you have like you have 3 sprites. First sprite, you show a 0 sprite. Second sprite, you show a 5 sprite. And third sprite, you show a 1 sprite, right? So I have an example here that we can do. If you want to follow along, feel free to.
So I have a question.
Yes.
I think we can calculate this formula, but it's very CPU expensive.
Not really. No.
Not really.
Not really. So you need to weigh your performance. So if you are suffering from frame rate drop because of this garbage collector coming in, then it's worth the while to do this. Yeah. Otherwise, if you're not, then you don't need to do it. So in the scene folder, I have a render order scene. You can open this scene up. And then in this scene, I have a canvas. Under the canvas, I have this text that I've disabled. You can enable it. And then I have this simple counter that's also disabled. You can enable that as well.